matter, we have come across the points where particle with duality of electromagnetic radiation, where and particle. So radiation, electromagnetic radiation having nature as a wave, having nature as a wave as well as particle also. Radiation having as a nature of wave and particle also. Where, for example, sunlight. Sunlight travels as in the wave nature, and particle, we see the explain photoelectric effect, and in photoelectric effect we see that radiation is observed in the form of particle. It indicates that radiation having dual nature. Listen carefully, students, and understand it. Radiation have wave as well as particle nature. That means light behaves as if it is made up of packets of energy. Light made up of packets of energy called as a quanta. We call it as a quanta. This word is important and term also important. So light quanta, we call it as a light quanta, can associated momentum particle nature. This light quanta can associated momentum can associated momentum particle nature. Momentum particle nature. So this term is important. What we say that light quanta can associated with momentum particle nature. Momentum particle nature. Now consider one example. When a stone is thrown in air, that means that object contains matter, that means matter thrown in air, that means matter having velocity, stone having velocity as well as mass. Stone having velocity as well as mass, and we know that mass into velocity we get momentum of that particle, and momentum is shown by the letter P. So matter consists of momentum, mass with velocity. Listen carefully, students. Since this light quanta means particle, bunch of particles, and that particles having momentum in nature, and this concept was confirmed. Light quanta having momentum particle nature, that means light quanta, smallest particle of light having momentum, that means that particle having mass and velocity also. The important is the particle having mass, smallest particle having mass, and if the particle having mass, it consists with a matter. So this concept, momentum particle nature, was confirmed by the scientist energy. These scientists conduct conservations or observations that X-rays behave like a maintenance Pauling walls in their interaction with electrons. That means his observations or the experiment by the experiments on scattering of X-rays. Experiment on scattering on X-rays due to electrons of matter. And from this experiment, this observation was confirmed that momentum particle nature. So what was the observation made by the scientist Compton on the momentum particle nature? So next point is observations made by the Compton on the particle nature. So observations. Which observations? That momentum having particle has momentum nature. First observation on the experiment on scattering of X-rays. Scattering of X-rays. By this experiment, first observation is made by the scientist Compton shows that photon is associated momentum along with the energy it carries. This is the first observation. Photon is associated with momentum along with the energy it carries. Photon carries energy with momentum. Second observation. These observations are observed by the experiment scattering of X-rays. Second observation, all photons of electromagnetic radiation of a particular frequency of electromagnetic radiation of particular frequency have the same energy and momentum. This is the second observation. That means, for example, this is the photosensitive metal and the electromagnetic radiation is incident on this photosensitive material. Then these radiations are bunch of particles. We call it as a quanta, and these quanta, for example, these quanta having the photons, and these photons having particular frequency. For example, this is the photons, and these photons having particular frequency. made by the scientist Compton on experiment scattering of X-ray. Third observation, photons are electrically neutral. Photons are electrically neutral and does not deflected by electric or magnetic field. These electromagnetic radiation containing photons, these photons are electrically neutral and does not affected by electric or magnetic field. This is the third observation. Fourth observation, photons can have particle. Photons can have particle like collisions with other particles such as electrons. That means photons can collide with other particles like electrons. These photons, see in this diagram, this is the photosensitive metal, plate, and fan. Electromagnetic radiation is incident on this metal. As soon as the electromagnetic radiation incident on the surface of this metal, these photons collide with the electron inside the metal. That means photons collide on the electrons inside the metal surface. Photons can collide with other particles. At the time of collision, photon gives its energy to electrons. Photon gives its energy to electrons or other particles. So, next important observation, in photon particle collision, energy and momentum of the system, energy and momentum of the system, are conserved. This is the important observations. When there is a collision between photon and electrons, the photon transfer its energy to the electrons. There is a transformation of energy and momentum of the system are conserved. That means the photons give its all energy and momentum to other particles like electrons, and the electrons gets all the energy from that photons. So there is a conservation of energy, transformation of energy from one particle to another particle. This is the important observation from this experiment we get. So momentum of the system are conserved, but the number of photons is not conserved. Number of photons at the time of transformation of energy, as the photon gives its energy to electrons, photons get disappear. फोटॉन काय करतो, त्याच्याकडची एनर्जी इलेक्ट्रॉनला दिल्यानंतर फोटॉन जो आहे तो काय होतो, डिसअपियर होतो. दॅट मीन्स number of photons is not conserved. So this is the important observation. Next observation. Observation number 5. Photons can absorb or new photons can be created. Photons can be absorbed, or new photons can be created. Observation number 6. Photons can transfer their energy and momentum during collision. As we see in observation number 4, photons can transfer their energy and momentum during collisions with the particles and disappear. Photons always move with the speed of light. Photons always move with speed of light. Speed of light. And last observation number 7. Mass of photon does not define. This is the important observation, student. Mass of photon does not define. Till today, the photon mass is not defined. That means the quanta having a photon and that photon mass does not define. Photonचं मास जे आहे ते मास किती आहे ते आतापर्यंत आपण फाइंड करू शकलो नाही. From this observation or from this experiment we get these 7 important observations, and these observations shows that the radiations having nature as in the form of momentum. Radiation having momentum nature, it indicates that radiation having mass, and the mass, that means photon mass, does not define. So up to these 7 observations we conclude that effect of wave nature of light, is observed in experiment, interference, diffraction, and diffraction. Conclusion of this chapter, that is light having wave nature, and this can be proved by the experiment, interference and diffraction. These terms is studied in chapter number 7. When we studied Young's experiment, double slit experiment, by this experiment we see that light is in the interference and diffraction. That means light having wave nature. These two experiments shows that light has a wave nature. That means electromagnetic radiation has a wave. Light, that means electromagnetic radiation having wave. Electromagnetic radiation having wave nature. Another two experiments like or another observations like photoelectric effect and black body radiation shows us that electromagnetic radiation it consists of photons. And these two experiments, interference and diffraction, shows that light has a wave. Electromagnetic radiation is observed in the form of wave. Similarly, some experiment on electromagnetic radiation like photoelectric effect, black body radiation shows us that electromagnetic radiation is in the form of photons. That means they having definite quantum energy. This phenomenon shows that the electromagnetic radiation having wave particle, that means as well as wave as well as particle. Photons, that means particle. One form is observed in wave, also in particle. That means in dual. So the chapter name is Dual Nature of Radiation. From these two experiments, we conclude that electromagnetic radiation is in the form of wave as well as also particle. So the phenomenon is termed as a wave particle duality of electromagnetic radiation. समजलं का विद्यार्थी मित्रांनो? हे इलेक्ट्रोमॅग्नेटिक रेडिएशन जे आहे ते आपल्याला वेव्ह नेचर मध्ये सुद्धा मिळतं बाय these two experiments आणि इलेक्ट्रोमॅग्नेटिक रेडिएशन using photoelectric effect किंवा ब्लॅक बॉडी रेडिएशन थ्रू तेच रेडिएशन जे आहे ते आपल्याला पार्टिकलच्या स्वरूपातही मिळतं. याचाच अर्थ असा होतो की इलेक्ट्रोमॅग्नेटिक रेडिएशन हॅविंग ड्युअल नेचर. Which nature? Dual nature, as in the form of wave, also in particle. So, next point of the chapter. Next point, de-Broglie's hypothesis. De-Broglie hypothesis. In 1924, in 1924, the scientist S.T.Bombale proposed that hypothesis tells us that if radiation has a dual nature, radiation has dual nature. Radiation has dual nature. He proposed that radiation has a dual nature, sometimes wave nature and sometimes particle nature. Then in nature there is a symmetry. In nature there is a symmetry. There is symmetry. In nature we observe that there is a symmetry exists in matter also. That means matter may also dual nature. Matter may also dual nature. Your concentration, student, it is the important point. What we studied up to this point, that means radiation has dual nature, wave and particle. Wave and particle. Now, the scientist S.T.Bombale considered that, or he proposed that if radiation has a dual nature, then in nature there is a symmetry. In nature there is a symmetry, and according to him, if radiation has a particle and particle consists with a matter, then matter may also have dual nature. Matter may also have dual nature. That means matter exists in wave form and also in particle form. Listen carefully. Matter also exists in wave nature and particle nature also. Now, how we prove this? So, normally we talk about matter as composed of particles. Matter composed of particles. For example, the chalk, each consists with the smallest particles. We call this as a one matter, and matter consists of particles. This is the main point. When matter is composed of particles, but matter seems to show as a wave-like properties. Matter particles से बनलेला आहे आपल्याला माहिती आहे. मग आपल्याला प्रूव्ह काय करायचं आहे? तर particles having wave nature. What do we have to find? Particles having wave nature. That means matter having wave nature. This is the important point, that matter consists of, or matter also having wave nature. So, on the basis of these proportions, S.T.Bombale consists of S.T.Bombale considered as, he used the properties of frequency and wavelength. As we have to prove that matter has wave nature. Matter has wave nature. Now, we know that wave, if there is a wave consists of the physical quantities. If suppose this is the sinusoidal waveform, it consists of wavelength. It consists of wavelength, frequency. In case of light, frequency we show it by nu. So wavelength consists properties of matter. If we consider the chalk, the properties of the chalk having mass. This chalk having mass, and when I throw this chalk in air, this chalk having momentum. So properties of matter having momentum, that means P, momentum, and chalk or matter having energy, E. This is the properties of matter. Now we have to show that matter having weight. So energy and momentum, these are the two properties of matter. The momentum P carried by a photon. If we consider a photon, now we consider a photon. If we consider the photon, the momentum P carried by a photon, the photon having mass and velocity. So photon containing momentum. Photon carried momentum. The momentum P carried by a photon of energy E. With an energy E. Then we consider there is a photon. In this photon having energy, momentum, energy and momentum. Now we are considering matter. And we know that matter having energy. And we show it by E. We know the familiar equation. Energy of matter E is equal to 1/2 mc square. 1/2 is the number, so E is equal to mc square. E is equal to mc square. Now we are considering here matter. So matter having velocity v, having mass m. By this we get the energy of that matter. So E is equal to mv square. Now we consider the electromagnetic radiation. And in the electromagnetic radiation, like this, electromagnetic radiation. So this radiation having velocity, and we write this velocity by the letter c. So this equation becomes E is equal to m multiplied by c square. E is equal to m multiplied by c square. So we get this equation like this: m multiplied by c multiplied by c. Or momentum. Therefore, I write this equation like this: m multiplied by c into c. We know that momentum of any particle P is equal to m into v. Now the particle is photon. Therefore, momentum P is equal to m multiplied by c. So we get the equation E is equal to m multiplied by c. That is the momentum of that particle. Therefore, E is equal to P multiplied by c. E is equal to P multiplied by c. So now in case of photon, this energy becomes E is equal to equation for energy for this photon. E is equal equal to P into C. Momentum multiplied by speed of photon. That means C. So P is equal to momentum is equal to equation becomes E divided by C. P is equal to E divided by C. Which is equal to, in electromagnetic radiation earlier in terms we see the equation for energy E is equal to h nu. So we substitute this value in this equation, we get h nu divided by C. So we get P is equal to h nu divided by C. P is equal to h nu divided by C. Again we know that wavelength of the wave lambda is equal to C divided by nu. If we consider it as a wave, then wavelength of that wave lambda is equal to C divided by nu. So substitute this term in this equation, we get P is equal to h divided by lambda. We get P is equal to h divided by lambda. De Broglie. Now what do we get? P means momentum of photon. Momentum is equal to h means Planck's constant and lambda, that means wavelength of the wave. De Broglie proposed that moving material particle of total energy E and momentum P has associated with a wave which is analogous to a photon. Now P is the momentum. We get the mathematical equation as P is the momentum. Momentum, that means it consists of particle, that means matter. And here we get lambda. Lambda, that is properties of wave. So observe this equation carefully, student. Momentum and wavelength. Momentum and wavelength. Particle and wave. Particle and wave, which is analogous to a photon. So he suggested that the wave has particle properties. I write here that nature is symmetry. Nature or symmetry. Nature is exists in symmetry. So P is equal to h divided by lambda. So de Broglie suggested that the wave and particle properties from this equation, wave and particle properties of matter can also describe by this equation for a photon. So frequency and wavelength of wave associated with material particle of mass m moving with velocity v and with v and is given by the equation lambda is equal to h divided by p. What is the conclusion of this equation? That wave and particle properties lambda and p, momentum, wave and particle properties of matter can also be described by this equation. Thus frequency and wavelength of wave associated with material particle of mass m moving with velocity v, which is also given as h divided by m into v. So lambda is equal to h divided by m into v. It indicates that matter also exists in a wave nature. So for today we stop here.